all because I think I'm not able to see the audience.
Hello, good evening, ma'am.
Yeah, audience are there?
Like, no, we three are from IEEE itself. Me, Joshin, K.S. Mahalakshmi.
No, but in the physical audience there.
No other audience are there. Only we are there.
No, in the hall.
No, it's not a hall.
No, in the university they are hosting, no?
No, ma'am. No.
No, this is you are from IEEE office, no?
Yeah.
You're hosting it from there, but there, I think once Rohit comes, he'll join and he'll showcase this thing.
Okay.
Your Mahalakshmi, you and this Martin. Martin is from Hyderabad.
Yes.
Joshin Martin, yeah.
No, but if he doesn't come, no, we cannot start it. No, Rohit should come.
Madam, yeah, I just reached, madam. Hello.
Rohit has come, no?
Yes, Rohit is. Yeah. We are about to start.
No, you can show the audience.
Yeah, audience are visible. Shall I show you from the other side? Yeah, let me show you.
My camera is not working.
Yeah. We have our webcam. These are the audiences.
Yeah, okay. Yeah.
Okay, and the professors are here. One another view this lecture. Yeah, you can. Shall I keep this webcam towards the speaker or audience? Hello, madam.
This is fine. Now let us start.
Yeah. Okay.
Hello, Varun.
Yeah, very good afternoon. Am I audible?
Yeah, you are audible.
Yes. First of all, I welcome you all for today's program, which is basically on disaster management by robotics and artificial intelligence. We welcome today our honorable speaker of the session, Mr. Abhimanyu Raja, and I have got his profile. I'll be just going through briefly. I also thank Madam Sadhna Atagwa, Madam, who is the director for Vishweshwaraya Museum. Thank you, ma'am, for giving the opportunity for our students to be part of such an informative session, which we are going to have right now. So let me brief out the profile of an eminent personality which is with us today. I request all the audience over here to grace the occasion with a big round of applause. Let me tell you, I have got the profile of a person who is appear to be very hardworking. The profile goes something like this. Sir is a BTech as far as his education is considered. He has done his BTech in textile engineering from PSG College of Technology. Sir has also done PG Diploma in Foreign Trade from World Trade Center, Hyderabad. Sorry, Mumbai. We do not have World Trade Center in Hyderabad. Sorry for that. Sir has worked with Voltas Group as a family member because his contribution has been exemplary. He has given his 6 years of career as a project engineer right from 1985 to 1991. He has handled various roles in the Voltas Group. He has also handled World Bank project, which has worked across the India. He has played various roles as an installation, commissioning, processing, productivity, quality assurance, etc. And I should tell you, Voltas has been proud to have such a hardworking person who has given his initial year of career, because I feel the person choosing a company to work in his initial year matter a lot, because that at that point of time we'll be having tremendous energy to deliver. And during 1995 to 2006, Abhimanyu Raja has been a founder and a managing director of TASTEX Consultancy. As a part of that, he has come out with a concept to complete execution of high-tech textiles and other industrial projects. The scope of the company, I could say that he has been an engineer, he has been a report preparation operations and finance fund mobilization. He was also into marketing tie-up and monitoring, execution, etc. From 2009 to 2017, he has worked as a director and a co-promoter for iTriangle Infotech Private Limited. I should tell you, this particular organization is India's leading telematics OEM, which ensures safety and efficiency of logistics with respect to GPS systems, which is basically known for tracking system and solutions. In the year 2016, Mr. Abhimanyu Raja, he has been a co-founder for a company, Janyu Technology Private Limited, a company which is engaged in robotics and automation. And probably we will be coming to know about this particular company's outcomes with respect to today's session. The company, which was based at Mumbai, has got many innovation to its credit, and they have also succeeded in delivering the defense-related project. He has been the managing director for Janyu Technologies. Apart from being a businessman, he has been also engaged in social activity, because I feel being a socially associated also gives immense happiness and pleasure, because we are a social human being. He has worked as a social organizer. He has been associated with various NGOs, and he has aimed to create a better India through technology and education to the youth. To add to its further credits, as a social human being, he has been mentoring the students of IIT Mumbai and many other institutions for developing and encouraging the entrepreneurship among the students, because these are the things the students get confused with, that they are actually an entrepreneur from inside. So he has encouraged many students who have been under him. And not only that, he has encouraged them to be part of one of the leading mission of our country called as Atmanirbhar Bharat. So this has been the profile of Mr. Abhimanyu Raja, and it has been very inspiring for me, because somewhere in my heart, even I am an entrepreneur, and even I want to be a Atmanirbhar Nagrik of Bharat. Thank you one and all for being so patient enough. Now I request Mr. Abhimanyu Raja sir to take over the session. Thank you, sir. Sir, the dais is all yours.
Yeah, I would also like to add to what Professor has told on behalf of IEEE Move India. and IEEE Hyderabad section, I extend a warm welcome to Professor Abhimanyu, and thank you for agreeing to give us a talk on disaster risk management using AI and robotics. And I think Snake Robo is one important application in disaster risk management. We would like to listen to your talk, and thanks to Mr. Rohit for arranging for this talk from IEEE Hyderabad section. Over to you, Professor.
Thank you, madam. Thank you for the kind words. This one?
Sure. This one, yeah.
No, say. Thank you. And normally I don't like to start with a regret, but I have to say a regret because we were stuck in BDL, right? We had some visit there in Bharat Dynamics, so we got delayed. So to start with, as so she was introducing me about entrepreneurship and the students. So I keep visiting the universities to tell the students that always you try the other possibilities beyond the job. We always keep working towards a job, towards a career, towards a salary. There is always another opportunity where we can be actually more useful for ourselves and for others in the form of entrepreneur, right? And people believe that entrepreneurship is, just having some ideas. It's not just ideas alone. We need some other aspects and the skill also. We can work on that, or if we don't have, we can always source it from the people who are in the industry, who are ready to help us. Right. Coming to this today's presentation, visible or will come out. Will we share it? Can someone help me out? It's okay. Okay. Right. See our company, how we are relevant to the disaster management or any area where there a human hazard is there. So we started in National Center for Excellence, the IIT Bombay, and the National Center for Excellence was created for risk mitigation to soldiers. So that's how it was created. So NCETIS, National Center for Excellence for Internal Security. That is the organization's name itself. So we were given problem definitions from the defense sector, and we were trying to mitigate that by our innovations. So our robots, what we did in the initial stages was meant for, rather it is also a kind of a human disaster, where the anti-Naxal operations, people, the soldiers who are involved in left-wing affected areas, they were getting hit when they were trying to explode the improvised explosive devices. When they were trying to detect it, they themselves stepped on it and they became a victim of that. So for that, we made a robot which actually senses the IEDs, and our robots can be operated from a distance of a kilometer or so. And once it is detected, then our robots can even diffuse it. Right? They open it up. They can replace or remove or even diffuse it in various techniques. So that is our first device. If you see our growth, we started with the robot. It's in National Center of Excellence for IED devices. We worked on that. After that, we have been giving one robot we call it. It's a small 5 kg robot. It is for national security guards. We did it, but it is also useful for any disaster purposes because it is very small in size and it can go into any debris or any areas. So if you see the size, it will be 1 feet by 1 feet, right? If you can see, 1 minute, I'll just show you that. This to your right side is that robot, a small one which can go into any area where it is actually. Which one? PPT is this one. Yeah, this going. Yeah, yeah, you see. Yeah. So this one, if you see that this is a small robot which can go into any confined areas or where the areas where we cannot reach physically. Right, the form factor is so low. In case of a building crash or an earthquake or a mudslide, whatever this equipment can go, and this is having a camera in all 4 directions. It has a night vision camera also, so we can operate it from a distance of up to 1 kilometer. So you will get the audio and video, both signals we receive, and it can climb up the steps or any other debris. It can, even if it is toppling, it can re-erect itself. It can actually form itself into a this, and it's totally battery operated. It has an endurance of around 3 to 4 hours. So this is an equipment totally designed by us, and we have got through the approvals of national security guards and all. Soon we may get into a commercial mode. And in India, we are around 14 companies who started attempting that, and we are the only company which is successful. The other company is a French company. So to your left, actually, you can see that is another disaster management useful device. Actually, we are doing it for the first time in India for DRDO. It's a quadruped, that is a 4-legged animal, literally an artificial animal which can go through any odd terrains. See, when you are having crawlers, we always have a problem of the surface. So the crawlers can crawl in a given surface, or it needs some sort of a surface to climb up or something like that. This is a typical animal like cattle or a donkey, which can go in any hard terrain. It can climb up. You must have seen in Ladakh, Leh Ladakh areas, we go in mules. It can climb up any hilly terrain, and we ride over that to go to odd places or to even climb a steep vertical hike. We use the 4-legged animals. Now it is a replacement of an animal with the robotic system, and this robotic system can be actually operated from a distance. Probably if we give a satellite connection, the headquarters say we operate per second. Presently, it is in a development stage where we have to deliver it next month. It is under assembly in our factory at Bombay. So this is one of the unique machines. We are only 2 companies doing it in India, and this is the first product. Each product is going to cost us a couple of crores. So here, now that we are making a smaller equipment, we can have a payload. It can be a big animal or as big as a horse, or it can be as small as a rabbit also. So since we are working on a platform, we have a 4-legged platform. You can take it like that. In robotics, this thing, we own a platform of both hardware and software. So we can miniaturize it, or we can make it bigger, depending on that. Though there are equipments available abroad, Boston Dynamics and other people have already made it. Their commercial versions available. But still, for India, in the Make in India concept, we are working on that. So both products we have been working for a couple of years, and now we have come to a stage of delivering the initial versions. So here, as engineers, most of you may be from the technical background, being a communication department, we have, for us, it is an engineer's paradise. Each machine, right from machine design guy to embedded systems guy, the programmers, the software guys, the computer engineers, almost all have their own passion to be displayed, and they can work at their will, and they have their creativity which can be implemented. So these are the 2 things, and we have given some devices. There is a big museum in Ahmedabad for Robosium. All robotics museum is there. So we are given a rescue and relief robot. If someone is there in the rubble, we have to pull him out, and then we can put them in a cart and move out. All things can be done by a remotely operated vehicle, because the debris may be active also. The collapse may be active also. It can collapse over a period of time. It is not that instantly it is done. It can happen after some time. It can further collapse. When we are trying to move out the rubble, then it can further be unstable. So in that conditions, to avoid further disaster of humans or further trapping, we can use the robotic systems. So robotic systems and the AI can be used in several ways. You must have seen a lot of news and stories that after 20 days or 30 days, still someone was alive. After 7 days, some child was alive. It's a news out there. So how do we identify them? So we have to, first of all, be in a silent zone and take the noise levels. So there is a technology involved in that. And to receive them or to feed them temporarily or to pull them out of that situation, we cannot go because the accessibility won't be there, or the spaces will be so confined. We cannot, send normal equipments. So we have to use equipments like smaller robots, throw boats, or snake boats, we call it. So these are all the inventions we have to do further, and we have to customize it as per our requirement. These communications, the feeding or the feeding the food material, food, water. One another thing is the oxygen levels. The third is taking them out. How to take them out? So we have several robotic applications because the disaster, either it's a mudslide or it is a building collapse or it's an earthquake, whatever it is, the situation will be dynamic in nature because it is not once done. Right. Even earthquakes, you must have seen that cascading effects. After a few days, again there will be a small rumblings. So after another few days, there will be further small rumblings. So the disaster is going to be dynamic in nature for some more time. It is not a one-time method. So in that areas, the remote operations and our robotic vehicles, which can be operated from a distance, and the data analytics from that, what is happening inside, how do you analyze that from the backend? These are all things which are going to help us in a big way. So down the line, if you see, the disaster management will be more technology oriented, right? And for that, we have to prepare ourselves, and these technologies will be useful for other industry purpose also. Because it is not the disaster alone. Even today we visited Bharat Dynamics. There are a lot of confined spaces and dangerous areas for human beings to go. So the similar technology can be utilized there also. So these are all some of our other inventions. I will come back to this one. This is a communication area. We are talking about communication. It's another very important thing in a disaster management situation, where a given area has to be temporarily actually given a network, because the existing networks must have collapsed already, either because of the rain, water, all the infrastructure, physical infrastructure must have collapsed. So we are working on communication. One is satellite-backed communication. Another is what you call it. We have microwave communication. Third, we are talking today. In fact, while traveling, I was with the professor. We were discussing on communications with the higher frequencies, Wi-Fi communication, which will have up to 1 kilometer, 2 kilometer radius. So with the different frequency, we were talking about unlicensed frequencies. Now what we are using is 2.4 gigahertz. So we can use the 5 and the 30 band, 30 gigahertz this thing, and make IoT devices. That's what we were discussing. So that may be our down the line, the next projects, because I'm basically from an IoT company where we have devices, IoT devices for tracking in telematics industry. So this is a typical coal field. We can it is akin to a disaster site where there is no actual communication available. So we have to give a communication network and then track the happenings around. So once we have the network, then the communications can happen. Then our remotely operated vehicles can give us the signal and the data. So that is another connectivity solution, right? Actually, this is my company profile. Actually, in case of mines, we can talk about the disaster site. So how do you create a communication network in a disaster site? That may be another interesting area. And that communication has to be instant. You have to create an instant networking, right? Either through a mobile vehicle, which has, trans receivers, or through some other mechanism, how to go about creating a communication network. That will be another solution we are talking about. This is a typical this thing. For those who are interested, I can give you further detailing of the communication. See, another thing we are doing is that the robotic sludge cleaning. Suppose if it is the disaster is in a water area, it is in a sludgy area, right? The mud comes in, or it is like a semi-solid. So how do you pump out that? Right? You cannot carry it physically; it is not rubble, right? You cannot just pump out because it is not water. So it is some sort of a slurry or a combination. So we have to use there also unmanned vehicles or robotic systems, which will actually pump out that. It happens particularly in mining areas when there is a disaster in a mine or something like that. If you see underground mines, we travel 1 kilometer down the line vertically. And at every 250 meters approximately, we have a side, this thing, what do you call, mine shaft, which will be running to around a couple of kilometers. So assume a vertical pipe, in that you will have horizontal branches. So 1 kilometer you go down the line, and every 250 meters you have a tunnel of 3 to 6 meter diameter tunnel. So you keep on making a hole out of it. I mean, drilling it, blasting it, removing that, again drilling it, blasting it, removing it. When you are doing it in underwater level, around 250 meters, 500 meters level, for every ton of mineral you mine, there will be at least 2-3 tons of water, because it's already 250 meters. Normally we talk about a borewell in 100 feet or 200 feet. Here we are talking about 700 feet or 1,000 feet. Right. So naturally we'll have a lot of water, and the water will not be pure. It is connected with the minerals, and it will be semi-solid in nature, or it will be very slicky in nature. So we can't just handle it, right, with the regular pumps. So the robotic system, which are equipped with the special pumps, have to be installed there, because disasters are not, I mean, though it happens instantly, the recoveries take a lot of time. Actually, to come to normalcy, sometimes it takes months. So we should have equipments on the technology level, which will actually mitigate the situation and bring the entire thing to normalcy. One such robot, what we are having, is a remotely operated crawler. It is operated both with the hydraulic systems, and it is also operated with the electrical systems, because electrical systems sometimes may not be, allowable because of the explosive nature of the given situation. In case of a hydrocarbon area, suppose the disaster is because of a hydrocarbon nature, whether it is through a gas pipeline blast or it is through a cylinder blast, we don't know. There may be some explosive material left out or explosive gases left out. So we can operate the entire robot through hydraulics. The movement of the robot now, including the crawling, the pump, suction pump, the robotic arm, everything will be operated through hydraulic actuators. So that way we are going to be sure that there won't be any explosion or any further disaster created by our devices. But our devices will be powerful enough to pull or to do the necessary job. So that is another equipment we are, already it is designed, it is in the market already. We are using it for industrial sewer cleaning and other purposes. So the same similar, this version, what you see in the screen is the hydraulic robot, which has got a robotic arm, a cutter, a crawling, everything are totally operated by hydraulic systems. The power pack will be far away. It can be as far as 100 meters away from the site. We can operate it through a camera. We can mount a camera in this robotic arm, and we can see the site, and we can operate it from a safe distance. This is already there. It is not, whatever I'm talking, we are already commercially in the market. Right. We are not talking about a project which is under development. There are some of the products which are under, we are developing further, but these are all the projects, whatever we are talking is already existing in the market. So these hydraulic things gives a lot of advantage for us regarding the safety perspective, also the power, and the power, I mean the takat. Right. The electricity and other things, even if it is not there, we can take it from a distant source, and we can do that. So these are all the equipments which you are talking about, remotely operated vehicles. Wherever there is this is a mine area, typical mine area. We are working on remotely operated vehicles to avoid disasters. So these are all under design stage. Soon we'll have, probably down the line 10 years, we'll have all our mines, right? We'll be prepared for a disaster, any disaster eventuality. Right. So this is actually, I cannot say directly it is connected with the disaster, but it is connected with the human touch. If you see this, what is on the screen is a smelter, right? The smelter is actually, we are taking aluminium out of an aluminium mineral, right? It's as good as sand. So in between anode and cathode, we pass around 20 to 25,000 amps current. So we create a temperature of 1000 degrees plus. So the entirely the sand melts. Okay, once the sand is melting, then the liquid aluminum will be going in the bottom and the other slags will float. Now, this what you see in the screen is called as a pot, right? This part is as big, I mean, as half of this hall size. I can say that it will be around 15 meter by 6 meter, okay, 15 meter by 7 meter by 5 meter. That will be the one part. So each part will have 12 electrodes, and those who are in science and technology, we understand electrodes need a current, positive or negative. We supply around 25,000 amps current. So what happens? The entire area is magnetic. Right. It will have a huge magnetic flux of up to 200 Gauss, which is not actually good for any human being. It is much more than what we can manage. But an operator now what's in the industry is that globally we just have an operator next to that machine. Right. He is exposed to one is magnetism, another is temperature. Then once he opens up that entire smelter, the gases come out, which is totally dangerous for them. Right. Whether it is sulfur or whatever the gases, hydrogen gases, all the gases which are actually injurious to health come out of that smelting pot. So now presently the operators are working in that situation only. So now we are giving a remotely operated vehicle where it can withstand the magnetic field, it can withstand the temperature, and it operates the gases atmosphere in the gaseous atmosphere also, because the body of the vehicle is made of composites which can withstand all this corrosion and other things. The operator can stand in a safe distance and operate it. So disaster, for example, we are talking about disaster in the outside. But what about the disasters inside the factory areas? So there also we need some remote operations and all. We are now directly exposing humans or the workers to this disastrous area, risky areas. So the human being is always put to risk just because it is his part of job. But if you see the industrialization or our own structures, that was not meant for human safety earlier. When we were colonized by the foreign forces, they were never bothered about our health or welfare. They were bothered about plundering the wealth. They were bothered about taking away our minerals as fast as possible. They were bothered about the natural resources being taken to their own place as fast as possible. So all the equipments and the work practices they were adopting were not having any consideration of a human, right? Any dignity for the human who is working. So now it is our duty, being youngsters, you are in the technology level, it is our duty to bring back the dignity of the humans through technology and by working on robotics and the artificial intelligence. See, robotics and artificial intelligence are part of each other, right? I'll slightly deviate. What is the intelligence part, right? Just for an understanding, because many people feel, not the people who are studying in AI, people outside, they feel that AI is something independent. It's not like that. It is as simple as a car, gearless car. Right. Earlier, our drivers were there. Driver A and driver B had his own behavioral patterns. So someone accelerates, someone breaks the brake pedal faster, all that. So now with this small intelligence, when you are giving to the machine, auto gear changes come in. Then speed, when you increase the speed, automatically the gear changes. So that way we are giving a small intelligence to the existing machines, which will make our life simpler. And it will avoid the human errors and the disasters. So this way, whatever we are talking about technology is just to mitigate the risk involved. So technology for risk mitigation, that can be one area, because when we are designing the machines, we should have it in mind always that should benefit a human being around who is working. So I'll try to give some more videos. And as a part of our upgrading ourselves on the technology side, we have our education centers we have our excellence center at universities. So one of that is that at Manipal, we have a research center where our students join with us, and our robots, we have them and we train them for dismantling entire robots and assembling it and maintenance of it, including software we teach them. So some of our reach to the students is to that not only enhancing the knowledge for the academic sake, it has to be useful for them as a business or as an enterprise also, because there are a lot of solutions we can give, right, as a small products for the enterprises. So these are all about some of our companies. Another interesting thing what we are talking about is that these are all our patents what we have. We have one Saturday talk sessions where we make many VIPs talk to our employees and other associated people, where they talk almost for 30 minutes, and there will be a 10 minutes question answer session. So the technology levels we are talking about is right from cryogenic engine to the latest level, this thing, what you call nanoparticles, people talk on that. So we are working directly with the students. I'm very privileged today to meet the students directly. So any one of you who are keen in working with us or learning further things can always interact with us. Since the notice was very short, I was not totally exhaustively prepared. I'll just run through once again if I missed out anything. So these are all directors and board of advisors. Yeah, I think I'm done with that. Any questions on this deployment of this thing and the communication systems and other things? I'm ready to take. Thank you. We'll show some videos. Sadhana ji, you have some questions to ask you. Please. Rahul, you have something to ask?
Now, can you tell us about that sludge cleaning robo?
Actually, sludge we define as some sort of semi-solid things, right? Which is sometimes not healthy. Also, it is injurious to health also.
So no, sludge cleaning robo in the sense on the roads, whatever sludges are there, it will clean. During floods, the roads get sludges.
Yes,
it is used for cleaning that.
Yeah, even sewer pipelines. See, manholes get choked normally, and the underwater pipelines, sewer pipelines get choked. See, if you see any city conditions after the floods or disaster, the underwater pipeline gets choked up. Even today, it is choked up only. We don't have any equipment to run through that one manhole to another and make the pipeline free of the legacy sludges. It is still there only. We are working with that equipment. We are trying to. We recently talked to Municipal Corporation Joint Commission.
And have you deployed it in the market, in Indian market?
We have done it in industries, madam. Now, in fact, last week I was talking to Niti Aayog people whether they can give 1 or 2 municipal corporations for us to deploy.
Where?
They are yet to decide. I was talking to Niti Aayog, Delhi. Yeah.
Okay.
Niti Aayog, Delhi. They are.
Okay.
Yeah.
Yeah, no, to this disaster response organizations.
No, if you can provide us an opportunity, we can do it. And otherwise, also Bombay Municipal Corporation Commissioner, Joint Commissioner has given us a permission for some 1.5 kilometers. This thing. Probably we'll be doing it after the monsoon. Yeah, that will be a big relief because that is going to literally burrow through the 1 meter or a 600 mm pipeline, which is underneath every city, right? And most of the cities are choked.
I have a small question. Students just beginning to all are basically are from first year.
Okay.
And some are from second year students. So how they can be benefited from this project?
Actually, we can talk about a lot of payloads. See, one pipeline we are sending a robot, right? Robot may be a big subject for them, right? As a whole machine. but they can add a small rather camera to it, and they can digitally take a data out of it. See, I was working with one engineering college. See, many colleges work with us. In fact, we have every year we have 3-4 study interns from some reputed colleges. See, some of the thing is that suppose we are talking about a pipeline, sewer pipeline, right? There is a cover, right? There is a manhole cover. The manhole cover can be attached with the this one sensors, right? For gas sensor, flow meter, or a level meter, whatever it is, so that we can preventively tell the municipal corporation that this is going to get choked up, or this is already choked up, or preventively we can tell. So small projects they can do. So yes, we can add on to the robot and get some more information to them, so that you can work on small smart solutions. Suppose 4 manholes you are connecting, and you are giving a smart screen. So today a municipal corporation or a commissioner or someone will know what is the status of my manholes. Right, like that we can add. Same way, if you are talking about, we are sending a vehicle inside. What kind of kachra inside nobody knows. Right, so we can design some cutters or some novel techniques to find what is inside. So we can talk about small GPR like radar JC, we can do ground penetrating radar JC. They can think on small solutions, because robot as a whole may be too big for youngsters. But
You see that India,
Yes.
we are talking about such power or something. We have maintained a blue box and green box. It is a bit,
Yeah.
Right.
Yes.
But mostly for combination of the both of them.
Yeah.
So as you had mentioned, is there any possibilities that we can differentiate the split wheel?
There are solutions, sir, already. Market may there are solutions. See, yeah, municipal waste segregation is a big subject, and there are solutions already available, particularly if you see BMC, Bombay Municipal Corporation, outside. There are huge factories where the municipal solid waste is segregated by default. Yeah, by default, they have some cameras, they have sensors. That's what I'm telling you. In that, we can do small projects. Right? How to, suppose you send it in a conveyor. Municipal solid waste is going in a conveyor. Or the waste we are talking, green and blue, jumbled up, both are going in a conveyor. We can have sensors to segregate and pluck it or throw it or divert it. So we can have various techniques. The boys can take it as a project, so they can do it.
So even we have seen regarding supplier,
Huh.
soil testing and all that.
Yeah.
Robotics is absolutely.
Yes. In fact, our team, we are from Mars Rover 2012 team. See, even today, Mars Rover 2023 chal rahi na. You have a club here, Mars Rover club. Many colleges have that. So every year they have a problem definition. In fact, I think if I'm right, March 2021, the problem definition was analyzing the mineral on the spot analyze. So we should have a probe which will give the data back. So one is a vehicle. So 2012 May, IIT Bombay was a runner-up, global runner-up. So my partner today, our team is from that Mars Rover 2012 team. Mr. Sai Hemant was the captain at the time. He is now my co-promoter. So where it was more vehicle, all-terrain vehicle was more important. Something which was crawling was more important at the time. Once we mastered that, then now we are talking about the payloads. What is a robotic arm and what is the sensor? First, robotic arm was important. Then robotic arm on a crawler ke baad, what is the sensor you use? What is the probe we are using? Then the backend analytics. So like that, it is evolving. So we can use that platform, need not create it, but we can understand that platform. But further value additions we can do. So like radars, no? What is inside we can understand from the top. Now what we are having is a metal detector only. Though even CRPF, though we call as mine detector, it is only has a limitation, lot of limitations. The plastic explosives can escape. Right? Still he can be injured, or still the bombs can explode. So we can talk about some small GPR, ground penetration radar, and we can understand like a literally scan of around 1 meter we can give. Children can take that projects. There are more of sensors and connecting the sensors and working with the backend. Thank you. Any other things? Thank you. Thank you for this opportunity.
Yeah, thank you, Professor Abhimanyu, for giving this excellent talk. You gave a lot of insights how robotics and artificial intelligence can play a crucial role in disaster relief management. And I also take this opportunity to thank Dr. Jamil Ahmad, Assistant Professor of the Manu University, Hyderabad, and IEEE Hyderabad section, and IEEE Move India, especially Mr. Rohit of technology team in IEEE Move India for coordinating and organizing this event at a very short notice. I hope we will have more such programs. Thank you, one and all.
On behalf of Manu, as well as from IEEE and the participants, I take this opportunity to propose vote of thanks for our resource person, Abhimanyu Raja sir. We are really enlightened by your knowledge and presence, and thankful, sir, for facilitating the program, and even also thankful for the participants for showing interest in this wonderful activity. Once again, thank you, everyone. Thanks a lot, sir.
Thank you.
Thank you, ma'am.